Welcome back, my orbital logistics coordinators. I'm your quantum superposed mission planner, simultaneously calculating launch windows across infinite realities. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your Mars sample return mission like a cosmic expense report that's been stuck in bureaucratic limbo since the Clinton administration. But before we dive into today's interplanetary delivery nightmare, I need to address something that's been weighing heavily on my quantum-entangled conscience. The Trump administration's proposed NASA budget cuts represent a historic threat to American space science leadership that would make even the most incompetent interdimensional bureaucrat blush with shame. We're talking about a 47% slash to NASA's science budget, eliminating 41 missions, including the very Mars sample return mission we're celebrating today. The ultimate cosmic irony: these cuts claim to support Mars exploration while simultaneously destroying the scientific infrastructure, international partnerships, and technical expertise that make Mars exploration possible. It's like canceling your delivery service while demanding faster shipping. Congress now holds the power to preserve American space science leadership or allow it to fragment under budget cuts so severe they'd make a Vogon constructor fleet seem reasonable by comparison. Because here's the thing about science: it's not a luxury expense item you can cut when times get tough. It's the foundation upon which our entire technological civilization rests. Every GPS satellite guiding your morning commute, every weather forecast saving lives, every medical breakthrough extending human lifespan, it all traces back to basic scientific research that someone, somewhere, decided was worth funding even when the immediate benefits weren't obvious. Speaking of immediate benefits that take decades to appreciate, today we're exploring the magnificent absurdity of Mars sample return, the most expensive dirt delivery service in the solar system. Our automated response system has been calculating shipping costs for 200 grams of Martian soil, and the executives have implemented a new Planetary Express premium policy, though I should note that our delivery guarantee only applies to realities where the laws of physics remain consistently cooperative and Congress doesn't cancel the mission mid-flight. Gather round the quantum loading dock, my cosmically coordinated colleagues, for a tale that would make even Neil deGrasse Tyson question his understanding of orbital mechanics, and Carl Sagan simultaneously weep and laugh at the beautiful absurdity of human ambition. In the fluorescent-lit realm of quantum improbability solutions, specifically in the Interdimensional Logistics Department, which existed in a superposition of perpetually behind schedule and mysteriously ahead of deadlines from the 1990s, Meridian Vex was having what could charitably be called a planetary alignment crisis of unprecedented proportions. It had started, as these things often do, with what appeared to be the simplest possible request: the square-haired boss, who occupied 17 corner offices simultaneously across parallel dimensions, but somehow never seemed to be available when you needed him, had personally assigned Meridian the task of organizing the delivery of a single test tube of soil from the QIS office in the Tau Ceti system back to Earth headquarters. A seemingly straightforward 12-light-year FedEx run that would, according to the initial project timeline, take approximately 6 to 8 standard delivery cycles, assuming normal space-time traffic conditions. That was 15 years ago. The soil sample in question, which marketing had already branded as Premium Exoplanetary Substrate Collector's Edition, had been sitting in the Tau Ceti break room refrigerator next to someone's leftover quantum casserole for so long that it had achieved its own orbital mechanics around a moldy sandwich that might have been there since the Carter administration. But here's where things get cosmically complicated. The soil existed in quantum superposition until observed by customs officials, meaning that every time someone tried to classify it for shipping purposes, it would randomly become either inert geological material or potentially sentient coffee grounds with interdimensional travel aspirations. 3 different departments immediately claimed jurisdiction over the sample. The Extraterrestrial Materials Division insisted it fell under foreign soil regulations, which required a 17-page customs declaration form that had to be filled out in triplicate using ink made from dark matter. The Temporal Shipping Authority claimed that since the sample had been collected during a lunch break that technically occurred last Tuesday, but wouldn't happen until next month due to relativistic time dilation, it required special chronological handling permits. Meanwhile, the Department of Improbable Substances argued that any dirt sample capable of existing in multiple quantum states simultaneously was clearly their responsibility, and furthermore, they suspected it might be trying to unionize with the office plants. But the real nightmare began when the square-haired boss announced that the delivery absolutely had to coincide with Earth Headquarters' quarterly budget review. Now, this might sound reasonable until you understand that QIS's quarterly budget reviews only occur during leap years and only in dimensions where the calendar contains prime-numbered months. This particular convergence happened roughly every 47.3 standard years, or, as the accounting department cheerfully referred to it, sometime between never and eventually. The Interdimensional Shipping Regulations, a document so complex it existed in its own pocket universe and required a PhD in theoretical bureaucracy just to read the table of contents, mandated that the sample maintain complete chain of custody across 7 parallel realities. This meant Meridian had to coordinate with 7 different versions of herself, each of whom had slightly different shipping priorities. Version 3 was obsessed with proper packaging materials. Version 5 kept insisting they should upgrade to expedited delivery, and version 7 had apparently gone rogue and was trying to mail the sample to herself using the interdimensional equivalent of a carrier pigeon. The International Space Cooperation Committee, Tau Ceti branch, kept changing their minds about which universal constants to use for trajectory calculations. First, they wanted to use the speed of light from Universe A. Then they switched to the gravitational constant from Universe C. Then someone in middle management decided they should average the physical laws from all possible universes, which resulted in equations that made quantum mechanics look like elementary arithmetic. As if this weren't complicated enough, the shipping route required an orbital rendezvous with what turned out to be a sentient filing cabinet from the Department of Lost Paperwork. This filing cabinet, whose name was apparently Gerald, though it insisted on being addressed as Filing System Administrator Gerald, 3rd Class, had been orbiting the Tau Ceti system for approximately 200 years, collecting and organizing every piece of interdimensional shipping documentation that had ever gone astray. Gerald, it turned out, was extremely helpful, but also pathologically obsessed with proper filing procedures. Before the sample could be transferred, Gerald insisted on creating a complete cross-referenced index of every form, permit, and certificate related to the shipment. This process would have taken approximately 6 months, except Gerald kept discovering small procedural errors that required starting over. "You've filled out Form 27B in blue ink," Gerald would explain with the patience of a being who had literally nothing but time. "But subsection 12 clearly states that interdimensional soil samples require black ink, unless the sample contains traces of dark matter, in which case you need the special forms printed on antimatter paper." The real crisis emerged during week 17 of the filing process, when Gerald discovered that the original soil collection permit had been signed with a pen that technically didn't exist in the same dimension as the soil sample. According to interdimensional shipping law, this created what Gerald cheerfully described as a delightful paperwork paradox that could only be resolved by obtaining retroactive permission from the past tense version of the Tau Ceti Department of Environmental Protection. Meanwhile, the Space-Time Customs Authority had gotten involved, demanding to know why a simple soil sample required an 847-page shipping manifest. The customs inspector, a being of pure bureaucratic energy who communicated exclusively through official forms, kept returning the paperwork with tiny, precisely written notes like "insufficient detail regarding quantum state documentation" and "please provide certificate of non-temporal contamination from authorized chronological inspection facility." By year 12 of the project, Meridian had developed what she called shipping Stockholm Syndrome. She had begun to genuinely care about Gerald's filing system and had actually started a small interdimensional book club with the customs inspector.
Hello?
The square-haired boss would occasionally appear via quantum teleconference to ask about progress, usually during important dinner parties, creating awkward moments where Meridian would have to explain to concerned family members why she was discussing soil transport logistics with a disembodied head floating above the salad course. The breakthrough finally came during year 14, when Meridian realized that the soil sample had been sitting in the break room refrigerator for so long that it had technically become office equipment rather than a shipping item. Under QIS's interdimensional property management regulations, office equipment could be transferred between locations using the much simpler furniture relocation protocol, which required only 23 forms instead of the usual 847.
Oh, yes.
But here's the beautiful cosmic punchline that makes this entire saga worthy of Douglas Adams himself. When Meridian finally opened the sample container for the transfer documentation, she discovered that the premium exoplanetary substrate was actually just coffee grounds from the break room coffee maker. The same coffee maker that had been broken since the Reagan administration and had been brewing a single eternal cup of coffee that existed in a quantum superposition of perfectly fresh and older than some planetary systems. The square-haired boss, when informed of this discovery, simply nodded sagely and announced that this made the sample even more valuable, since it represented the longest continuous brewing experiment in corporate history and should definitely be preserved for future generations of interdimensional coffee enthusiasts. Gerald the filing cabinet, upon learning that 15 years of meticulous documentation had been devoted to organizing the shipment of interdimensional coffee grounds, experienced what could only be described as filing system enlightenment and immediately promoted itself to Senior Archive Management Specialist, Coffee Division. And somewhere in the quantum foam of bureaucratic possibility, Meridian's 17 parallel selves are still trying to figure out whether this counts as a successful delivery or the most beautiful failure in the history of interdimensional logistics. And that, my quantum-entangled colleagues, perfectly captures the magnificent absurdity of Mars sample return. A mission so complex, so ambitious, and so utterly dependent on everything going exactly right across multiple planets, international space agencies, and congressional budget cycles, that it makes Meridian's coffee ground crisis look like a simple trip to the corner store. And that brings us to the fascinating science behind Mars sample return, the most ambitious logistics operation in human history. Unlike Amazon Prime's 2-day delivery promise, this phenomenon actually follows the unforgiving laws of orbital mechanics and congressional budget cycles. What we're talking about here is essentially the ultimate cosmic delivery service, collecting 200 grams of carefully selected Martian soil and rock samples, launching them off the surface of another planet, catching them in Martian orbit, flying them back across 140 million miles of space, and somehow getting them safely to Earth laboratories without contaminating either planet or accidentally creating an interdimensional incident. It's like playing catch with your friend while you're both riding on different merry-go-rounds that are spinning at different speeds, in different directions, while blindfolded, and the ball weighs as much as a small car. The historical context makes this even more remarkable. We've been trying to understand Mars since the 1960s, starting with simple flyby missions that basically amounted to cosmic drive-by photography. The Viking missions in the 1970s were our first serious attempt to answer the big question: is there life on Mars? But their biological experiments gave us tantalizingly ambiguous results that scientists are still debating 50 years later. Fast forward through decades of increasingly sophisticated rovers, from the golf cart-sized Sojourner to the SUV-sized Curiosity to today's Perseverance, which is essentially a rolling chemistry lab with 17 different instruments and its own helicopter sidekick. But here's the thing. Even our most advanced Mars rovers are like trying to perform brain surgery with oven mitts. They can tell us amazing things about Martian geology and chemistry, but there are some questions that can only be answered by bringing samples back to Earth laboratories equipped with instruments the size of entire buildings. The staggering statistics alone should make anyone question humanity's collective sanity. We're talking about 15+ years of planning, international coordination involving NASA, ESA, and multiple space agencies, billions in funding that makes most Hollywood blockbusters look like student films, and all of this effort devoted to returning 200 grams of dirt. That's less than a cup of coffee, folks. The mission requires launching 3 separate spacecraft: Perseverance, already on Mars collecting samples, the Sample Retrieval Lander, scheduled to launch in the late 2020s, and the Earth Return Orbiter, which has to play cosmic interceptor. Each of these missions has to work perfectly across multiple launch windows, with zero tolerance for the kind of close-enough thinking that works in most other human endeavors. And unlike ordering pizza, if something goes wrong, you can't just call back and ask them to try again next week. You're looking at waiting 2 years for the next planetary alignment. When we return from this brief planetary conjunction, we'll dive deeper into the cosmic choreography of launch windows and explore why missing your delivery window doesn't just mean an angry customer. It means waiting 2 years for the planets to align again, explaining to Congress why you need another $1 billion, and probably having to start over with entirely new hardware, because space technology has the shelf life of fresh produce in a universe that operates on geological timescales. Welcome back, my astronomically aligned administrators. While you were away, our automated response system has been calculating the carbon footprint of shipping soil across 140 million miles. Spoiler alert, it's roughly equivalent to powering Luxembourg for a decade, but with significantly more rocket fuel. Meanwhile, executives at Quantum Improbability Solutions have been brewing some new ideas about sustainable interplanetary commerce. though I should note their definition of sustainable involves harvesting dark energy from coffee beans and implementing a company-wide policy requiring all interdimensional travel to be carbon neutral, which is surprisingly easy when you realize that carbon doesn't technically exist in most of the dimensions we operate in. Now let's talk about why Mars sample return makes every other logistics challenge in human history look like delivering pizza to your next-door neighbor. We're dealing with what I like to call the tyranny of launch windows, a phenomenon so unforgiving it makes your most demanding boss seem reasonable by comparison. The tyranny of launch windows is fundamentally about the fact that planets don't care about your schedule. Every 26 months, that's 2.14 years for those keeping track, Earth and Mars align in what's called a synodic period, creating optimal conditions for energy-efficient interplanetary transfer. Miss this window, and you're not just late for a meeting. You're looking at a minimum 2-year delay and exponential cost increases that would make a defense contractor blush. Unlike your morning commute, where you can take surface streets if the highway is jammed, space operates on the principle that there is literally no alternate route. The laws of physics don't offer a scenic route option when you're trying to get from one planet to another. But here's where it gets cosmically complicated. We're not just talking about one launch window. Mars sample return requires a carefully choreographed sequence of multiple launches across several years. First, you need to launch the sample retrieval lander during one window, then the Earth return orbiter during another, and each of these spacecraft has to arrive at Mars at precisely the right time to coordinate with Perseverance's sample collection schedule. It's like trying to coordinate a flash mob where all the participants are on different planets moving at different speeds, and if anyone shows up late, the whole performance is ruined and you have to wait 2 years to try again. The cosmic choreography involves understanding that rockets fundamentally don't work like FedEx trucks. When FedEx wants to deliver a package from New York to Los Angeles, they can pretty much leave whenever they want, take any route that makes sense, and arrive whenever is convenient. Space doesn't work that way. In space, you're not just fighting distance, you're fighting orbital velocity, gravitational fields, and the fundamental physics of energy conservation. A Hohmann transfer orbit, the most energy-efficient way to get from Earth to Mars, takes about 9 months and requires launching at exactly the right moment when the planets are positioned correctly. You can opt for higher energy trajectories that get you there faster, but that requires exponentially more fuel, which means bigger rockets, which means exponentially more money. This is why rocket scientists have a reputation for being slightly more uptight than your average delivery driver. The beautiful irony is that we've gotten so good at orbital mechanics that we can predict exactly where Mars will be 9 months from now, down to the kilometer. But we still can't predict whether Congress will fund the mission 9 months from now, down to the nearest $1 billion. Physics is reliable. Politics, as Meridian Vex learned, operates according to its own mysterious laws of bureaucratic orbital mechanics. The ultimate science question that justifies all this complexity is deceptively simple. Why is 200 grams of dirt worth $10+ billion? The answer reveals why Mars sample return represents one of the most important scientific investments in human history. First, there's the potential for signs of past or present Martian life. And we're not talking about little green men, but microscopic evidence that life might have evolved independently on another planet. Finding even fossilized microbes in Martian rocks would fundamentally change our understanding of biology, evolution, and our place in the universe. It would prove that life isn't a cosmic accident unique to Earth, but a phenomenon that might be common throughout the galaxy. But the scientific value extends far beyond astrobiology. Understanding planetary formation and evolution requires detailed analysis that's impossible with current Mars-based instruments. Earth-based laboratories can perform isotopic analysis, organic compound mapping, and mineral dating with precision that's literally impossible to replicate on Mars. We're talking about instruments the size of buildings, operated by teams of specialists, capable of detecting molecular signatures that could reveal how planets form, why Earth became habitable while Mars didn't, and what conditions might support life elsewhere in the solar system. Perhaps most importantly, Mars sample return serves as technology development for future human missions. Every aspect of the mission — precision landing, sample collection, a rocket launch from another planet's surface, orbital rendezvous, and contamination-free Earth return — represents essential capabilities for eventual human Mars exploration. We're not just bringing back dirt. We're developing the technological foundation for humanity's expansion into the solar system. Well, my celestially synchronized subordinates, we've reached the end of another quantum delivery nightmare. Today, we've learned that in the multiverse of interplanetary logistics, every sample return mission exists in a superposition of groundbreaking scientific achievement and bureaucratic catastrophe until someone checks the budget. We've discovered that Mars sample return isn't just about bringing home 200 grams of dirt. It's about proving that humans can execute a plan spanning decades, multiple countries, and the whims of planetary orbits. It's about demonstrating that our species can think beyond quarterly earnings reports and election cycles to accomplish something truly magnificent. When we successfully return those samples to Earth laboratories, we won't just be analyzing Martian geology. We'll be proving that humanity can overcome its own organizational chaos to achieve something that would have been pure science fiction just a generation ago. And if you've enjoyed today's interplanetary adventure, why not share it with a fellow space logistics enthusiast? Perhaps you know someone who's ever wondered why we can deliver pizza in 30 minutes, but it takes 15 years to return soil from Mars. Share our signal like cosmic background radiation spreading across the universe, preferably to people who appreciate both good science and the beautiful absurdity of human ambition. But here's the serious part, my quantum-entangled colleagues. Mars sample return and missions like it represent more than just scientific achievement. They represent our commitment to understanding our place in the universe. The proposed budget cuts threatening this mission aren't just numbers on a spreadsheet. They're decisions about what kind of species we want to be. Do we want to be the civilization that reached for Mars and brought it home, or the one that decided 200 grams of potentially life-bearing soil wasn't worth the investment? If you're an American listener, please consider contacting your representatives in Congress. Tell them that science isn't a luxury expense. It's the foundation of everything from GPS satellites to medical breakthroughs, to the technologies that might one day make us a truly spacefaring species. The budget that funds Mars sample return today funds the discoveries that will transform human civilization tomorrow. This is your quantum coherent correspondent, reminding you that in the multiverse of space exploration, we're all just waiting for our launch window while hoping the funding doesn't get cancelled. But unlike Meridian's interdimensional coffee grounds, the samples waiting on Mars represent genuine treasures that could answer fundamental questions about life, the universe, and whether we're alone among the stars. Remember, somewhere in the quantum foam of bureaucracy, Meridian is still trying to explain to the square-haired boss why delivering dirt requires a multi-decade international conspiracy, the patience of geological timescales, and the unwavering belief that some questions are worth answering regardless of the complexity involved in getting the answers home.
The Multiverse Employee Handbook was created by Rob Corrigan. The host, David, is a professional voice actor who has digitized his voice through 11 Labs voice cloning technology. All episode thumbnails are created with OpenAI, and music and sound effects come from Pixabay, which are generated by human artists. Everything else, the writing, jokes, research, sound editing, and coffee consumption, is 100% human-made by a human. No cats are harmed in the making of this podcast. Visit our website for more information about the Multiverse Employee Handbook.